Hello everyone, welcome to Kubernetes cluster configuration using kubectl on Amazon Linux or RedHat. So this is Nilakanta from Prism Technologies. So before going to this session, let me explain or show a little bit about Kubernetes cluster. So the Kubernetes cluster will be like this. So it will have master and worker nodes. Whatever the operations we do on Kubernetes, that has to be done by connecting to the master itself. So even we can have multi masters as well. So as of now in this session, I'm going to continue with the single master and two worker nodes. We can have any worker node, any number of worker nodes, and I'm going to go with two worker nodes. In general, to configure this Kubernetes cluster, we need to minimum two instances, one master and one worker node. In this session, I'm going to take one master and two worker nodes. When you are working with Kubernetes configuration, you have to do all the operations by connecting to your master itself, right? So by connecting to master, so I can execute using any commands related to master using CLI, or I can operate with using GUI or else any programmatic languages API, right? So this is a brief architecture explanation. If I want to explain in this, it will be like this: the master, worker nodes, and my master will have the components like API server, scheduler, controller, manager, etcd, and the worker nodes will have this kubelet, proxy, and Docker. So if you want to understand in this these things in detail, and if you want to understand about Kubernetes, watch my other videos on Kubernetes, right? So for this, I have already created three instances. One is master and two worker nodes. To work with this, the master to work with the Kubernetes master worker node configurations, you need the master with minimum 2 CPU and 4 GB RAM. Minimum is that 2 or 4 GB RAM you can take, and minimum is 2 CPUs. So for that, I have taken this master instance as T2 medium and the worker node as T2 micron. I already created these instances in my AWS account, and then these are running. So for now, let me connect to my master and execute the required commands, right? So let me copy this, and I'm not using any username or password. I'm directly connecting through PEM file. This is a PEM file I have used to connect to that instance. So I'm going to connect like this. Okay, let me switch as root user. I switched as root user, and I have to execute few commands on this. So in this first I have switched as root user. Then what I have to do is first I have to disable firewall D, and then I have to turn off the swap. Right? First, let me stop the firewall and then disable, because in the current versions it is not supported. So in future versions Kubernetes may support. So first we have to disable this. In the current versions, swap memory is not supported, so that's why we have to turn it off. I'll share this document as well. You can follow this. Sorry, I'm turning off disabled firewall and then turning off swap. So you remember these commands I'm executing on master, and I have to execute the same on all the worker nodes as well. So after this, what I have to do is, after disabling this, I have to create one repository file. So kubernetes.repo. I'm going to create using cat command. I'm going to create this file under this location /etc/m.repos.d/kubernetes.repo. This file I'm going to create, and this I'm going to keep all the packages required for Kubernetes, right? Then I have to update update -1, right? So this will take time. After that, you have to install Docker and other like daemon, kubelet, and other components required for your Kubernetes. So it will take some time to install all this. Right, it is done. Let me install Docker and other components. Right. Once it is done, if in this case, you make sure that Docker is installed properly. If Docker is not installed properly, if you get any error message, try to install Docker using these commands. But I hope that will not get any issues. Expect that. So no issues are there with the Docker. So I no need to execute these commands. Now let me start Docker and enable it. So I'm going to enable this using this command. I'm going to enable my Docker so that even on a system reboot, my Docker gets started automatically. Then the next command I'm going to With this command, I started my Docker. Now I'm going to start kubelet as well. I enabled it and started. Then I'm going to create another file which is related to IP tables. This inside a table. Right. Execute this command. If you get any issue with whenever you are executing this command, then you have to execute this command first and then this, but I haven't get any issue. So I'm going to ignore this and then continue. Right. Then I have to reload the daemon. If you are not aware of what is the daemon and all, Kubernetes components, you just watch my other videos. I have explained Kubernetes in detail. Now I restart my kubelet. That's it, guys. Now what I have to do is, now I have this instances, 3 instances. In this one only I have to take as master. So this I consider as a master. So how can I let my Kubernetes know I'm considering this as a master is using kubeadm init command. Wherever in this cluster instances, we have taken 3 instances, right? In this, wherever the instance, whatever the instance I execute kubeadm init command, wherever I'm executing this init command is there, right? So that will be considered as your Kubernetes master. And the IP network range, pods network CIDR range I am giving. So based on this CIDR range, your Kubernetes network will be created. It means this many number, based on the CIDR range, those many number of pods can be created inside your network. Right? Every pod will have its own IP address, right? Based on that only it is going to create that network. Right, whatever the CIDR range I have given. So whenever you execute this command, init command, that will be considered as master, and it will generate few commands for you. Let it generate, then I'll explain what is each command. See here, kubeadm init has given view commands here. If you read here, your Kubernetes control panel has initiated successfully. To start using your cluster, you need to run the following command, following as a regular user. See this, you have to execute these commands on your master itself using a regular user. So let me execute one by one. So before that, let me take a copy of this entire thing in a notepad. Then let me execute one by one. So I'm going to create a directory, whatever the kubeadm init command has executed, same 3 commands I'm going to execute. One more thing, sorry guys, I have to execute this as with a normal user, right? Not with the root user. So let me exit from that user and then execute. So I'm using EC2-user. I'm going to use EC2-user. With that user, I'm going to execute all these 3 commands. So what does this contain is, this is a file which has all the information about your Kubernetes master and worker nodes. What is this master? What is the IP address? What are the worker nodes connected to this in this cluster? What their IP address? Everything, all that information, how it has to connect internally with the authorization, all these things and all will be there inside this conf file. So I have done with this. Now what I have to do is, if I execute any command, let's make sure that whether our Kubernetes is installed as properly on our master and we are able to access the commands or not. kubectl get pods. So kubectl is a client what we use to execute the Kubernetes commands. Kubectl get pods. No resources found. There are no resources found, but our Kubernetes commands are working. Means we configured fine. --. I'm going to execute one more command. kubectl get pods --, all name spaces. So see here, there are something getting created. Those are in 2 are in pending, 2 pods which are related to internal to your Kubernetes. 2 are in pending state, few are in running state, right? Now if you see here, if you want to check the nodes, as of now we have only one node in our Kubernetes cluster, that is master. If you want to see that, kubectl get nodes, if you type this, it is saying that there is only one node, that is the master node, and it is not ready. It is not ready. We have the master, but it is not running. It is not in a ready state. So for this, what we have to do is we have to add a plugin, right? I have to add one network related plugin. See here, it is a DNS, core DNS. These are in still pending in state. Those are not running. So I have to make them up. So for that, what I have to do is I have to add a network related plugin. So we can add a plugins like, you don't need to configure the Kubernetes network. You don't need to bother about that. Just you need to add plugins. So there are plugins like Calico, Flannel, Wave plugins. so that you can add. So I have used this, right? I have executed this. So I want to add a plugin. So this plugin you can add, but make sure that when you are adding a plugin, it is compatible. This plugin version is compatible with Kubernetes version, right? So this is not compatible. Even I tried this, this will not be compatible. So let me check the latest one. So what you can do is you can just search here Flannel plugin. I'm planning to go with the Flannel plugin. You can just Flannel plugin for Kubernetes. We search with this. So you can just open this site, cluster networking Kubernetes. So if you get into this, you can search here Flannel like this. If you go down, okay, there will be like Wave, so many things, right? Calico is there like this, right? So I'm going to go with the Flannel itself. So just click on this. It will give the commands here. See here, Kubernetes v1.7 onwards for Kubernetes. That version I'm going to use this plugin. So let's me add this plugin. Added this plugin. Now if you type this kubectl get all namespaces, it is getting running. See here, it is getting initializing something. But before that, let me do one thing. Kubectl get node. Kubectl. Now if you see here, your master is in ready state. Your master is in ready state. My master is configured. Now I have to configure the worker node. So let me take this worker node, one of the worker node. Let me connect to this. So I don't want to connect to master. So I'll use the worker node. Right. So just not to create any confusion, I'm closing this terminal, which I'm closing this, and I'll use a new terminal to connect to my worker node. So I'm switching as root user, and I'll execute the same commands, whatever I have executed, right? Till this kubectl init. You should not execute this on worker node. Wherever you are executing this command, that will be considered as your master, right? Until this, except this, before this, whatever the commands you have executed, you have to execute all those commands on your worker nodes, each worker node. Okay, let me add this quickly. So I already explained it. This swap is not supported. This versions of Kubernetes in future they may support. For now, I'm going to turn it off. And make sure when you are using this Kubernetes cluster, you have allowed the required port numbers. I'll tell you the required port number, but as of now, I have allowed all the traffic in my security groups. After this, I'm going to update my worker node. So now I'm going to execute this installation and make sure that Docker is installed properly. Everything got installed successfully without any issues. So I don't need to execute this command. So I'll start my Docker and enable it on system reboot. So the same way I'll do it for kubelet as well. Right now I'll create this file related to my tables. The same thing, whatever you have done on master, that you have to do it. No, this is not going to be executed. Sorry, that is the reason it has shown here. It is not an issue. Reload my daemon and then is that kubelet. That's it, guys. I configured my worker node. So I have configured this master. If I explain this, I have configured this master and I configured worker node, but there is no cluster configuration between these two. So for this, what I have to do is whenever you have initiated this kubeadmin init command, kubeadm init command, it has given a join keyboard. It has given a join keyboard. These commands you have to execute on master itself using a normal user, and these commands you have to execute on your worker node. This is a join command. Wherever you execute this command, that will become as your worker node to your master. So you see here, then you can join any number of worker nodes by running the following on each as root. So I'm going to execute this command on my worker node. See here, this join command. So this will get joined with my master. See here, kubectl, run kubectl get nodes on the control panel to see this node join on the cluster. This I don't want to execute this because whatever we perform, right, those has to be done from the master. So let me connect to my master. Right, I'll open another git bash, connect to my master, and then I'll type, because these commands, whatever the commands you executed, right, with the what user we have executed with the ec2-user, then you can execute all the commands using that ec2 user only. kubectl get nodes. At this, see here, one master is ready and the worker node is also ready. So I'm going to pass this video and I'm going to repeat the same steps on worker 2 as well, because I want to reduce the length of the video. So I'll do the same steps on worker node 2 as well and come back. Till that, I'll pass my video. See here, this is the worker node 2. I have executed all the commands till here. So till here, so I haven't executed this because this has to be executed only on master. Till this, I have executed here as well. Now here also I have to execute the join command. So wherever I want, whatever the instance I want to join with my master, there I have to execute this join command. I'm going to execute this join command on my worker node 2 Linux instance. Now I'll go to my master. So again, I'll go to my master and connect to my master and type kubectl get nodes. Let's see what will happen. Right? So kubectl get nodes. See here, one master and 2 worker nodes. Right? This, if you want to cross check, you can cross check from here. Master, what is this? 172.3142150. Right? Now if we go to worker node 1, 3866 and 34233 for worker node 2. Right? 4323 43234. Right? These are the ones. Now you remember one thing, but one of the important, that is this join command is not a permanent command. It will have some expiration time. It will not work for after some time. Then what I have to do, if after 10 minutes or after an hour, after 1 or 2 days, I want to add the instances. As of now, I have 2 worker nodes. In future, I want to add extra nodes, worker nodes to my master. Right? Then what should I do? Because this key will expire, right? There is one command called a kubeadm generate token. Okay, create token. One command is there. You can search Google for this. So using that token, you can recreate another token and you can use that token. Even that token, newly created token will have some expiration time. So whenever the token gets expired, you can create a new token and use that. Right? Fine. And if you have used AWS auto scaling configuration, so in that case, how you do? Because based on the load, the instances will get increased. So in that case, you don't need to manually go and join the newly created nodes, because those are auto created nodes. So in that case, what we are going to do is the newly created nodes need a custom AMI. So we are going to take any one of these worker nodes and we are going to create our custom AMI, Amazon Mission image, using these worker nodes. And we use this now to create the AMI, and using that AMI only, we launch the new instances in auto scaling. So that's the reason in auto scaling, if you do it in such way, then we no need to add the join key manually. Because if we create any AMI using this any of this instance that already has joined, right? So whatever the instance you are creating from that custom AMI, that will automatically gets connected to your master. Fine. Now I just want to create one small pod.yml and see that how it will be. Right? I am going to create one small pod. Here, you have to execute this only on master, right? So I'm going to create vi sample YAML I'm going to create, insert. See, I'm going to create one pod, hello pod, and it is going to take the Jenkins image and it exposed with 880 port number, right? So how to create this? kubectl create you can use, or apply will create and apply, right? But it is better to use apply always, so that it will be recorded. So with this, we how to create a pod, replication controller, and all the component kinds we will see in further classes. Watch my videos. So here a pod has been created. kubectl get pods. Sorry guys. Get pod. See this pod is getting created. Okay, container creating it is showing. Okay, we'll wait for some time. It gets created. Right, the pod is in running state. What is this name of the pod? This is one inside my pod. I need one container that is running state. Right now, I want to know on which worker node this pod is running. See this is running on this worker node 43238. 43238 on worker node 2. That's it, guys. This is how we configure Kubernetes cluster, and we'll see in detail how to work with Kubernetes. Everything we will see from end to end on next session. Thank you, guys.